Okay, so since we didn't have time to get through all these notes in class, I want to go through and do the example for a confidence interval for the difference between two means with you. The first thing I want to look at is obviously the question. So Ashton and Olivia want to know if generic chocolate chip cookies have as many chocolate chips as name brand chocolate chip cookies on average. To investigate, they randomly selected 10 bags of Chips Ahoy cookies and 10 bags of Great Value cookies, and randomly selected one cookie from each bag. Then they carefully broke apart each cookie and counted the number of chocolate chips in each. Here are the results. So we have for Chips Ahoy, these are the numbers of chocolate chips that they found in each one. I'm just going to put a little C over here because I'm going to talk about that group as C and this group as G. Okay, let's see. We will not be pooling. Okay, so construct and interpret a 99% confidence interval for the difference in the mean number of chocolate chips in Chips Ahoy and Great Value cookies. So this is what we're trying to do. And so our first step in our 4-step process, we'll do state. And what we want to do is we want to estimate the true difference in the mean number of chocolate chips in each in the cookies between Chips Ahoy and Great Value with 99% confidence. So that's what we're going to say here. And then we'll go ahead and I'm going to call them for the population mu C and mu G. Okay, so I'll say trying to fit it all on the screen, but it's a little bit difficult, so hopefully that's good enough. And then I am going to go ahead and denote the direction that I'm subtracting, so mu C minus mu G. Right, so again, we expect the name brand to have more, and so that's why I subtracted in this direction, just to make my values mostly positive. Okay, so plan. We're going to do a 2-sample t interval. All right, random. It was stated that they randomly selected 10 bags of each type of cookie. %. We can say, I mean, that's obvious. That's reasonable to say. So you say 10 times 10, that's 100. I think it's pretty obvious that it's reasonable that there are more than 100 of each type of cookie here. Okay. Our large counts or normal condition. This is another situation where we fail on the large counts. We do not have at least 30 pieces of data for each set, which means that we need to graph these. And so in order to do that, I'm going to go into my calculator, my spreadsheet. I'm going to title each of these. I'm going to use CA I'm using 2 letters just because otherwise the calculator will ask me some extra questions whenever I go to graph this, and this is just easier. So GB. And I enter in my numbers. And that should be right. So 10. Okay, so I have all my data in here, and so I know I need to go into here and make a graph. First, I'm just going to do the Chips Ahoy first. I'm going to look at the box plot in this case. I just think it's going to be easier to draw more quickly. So I'll go ahead and menu, plot type, box plot. Okay, there's my box plot. Let's see. The other one's going to have the bigger range. So I take it back. I'm going to change this and do the other one first, just so I can use the same scale for both. Okay, so I know that I need my scale to go from 14 to 26. Okay. Hovering over, I can get the 5-number summary. I could also actually, just to kind of show y'all, remember that I can get these from my 1-variable statistics in the spreadsheet also. So I can go through here and say menu, stats, calculations, and then 1-variable statistics. Let's see, I was doing, which one? I can do both. I'll do Chips Ahoy first. So if I choose that, then I get my 5-number summary here. So minimum is 16. I'm going to say this is CA up here. Minimum is 16. Q1 is 17. Median is 18. Q3 is 20, and the maximum is 21 for those. So there is my Chips Ahoy box plot. Probably not the prettiest box plot you've ever seen, but it does the trick and the scale is correct. And then for my grade value, I'm just going to collect my 5-number summary for that. So for 1. So grade value, I don't care where it is, so I'm going to leave it in G. Okay, so now over here in G I have these. So my minimum is 14. Oop. Over there I already wrote on top of it. That was stupid because I made the scale for that. Okay, so Q1 is 17. Median is 19.5. Q3 is 22. And max is 26. That's right, that's why I made the scale that way. Okay. Okay, so I'm just gonna make my statement. Can we see that? Yeah. That last word is just T procedures if it cut off from the video. Okay, so now on to the do step. So I'm probably just going to overwrite some of my data here because I've already got those 5 number summaries, so I don't really care anymore. Okay, so for my do step, I'm going to do this from the spreadsheet because it's been giving us some problems whenever we do it using the scratch pad. I don't know why. So if I go here and I say menu, statistics, now I want a confidence interval. So I'm going to choose 3, and I want a 2 sample t interval. My input method is data. Tell the calculator where your lists are. And I want to compare CA to GV. Our confidence level was 99%, so we're going to put 0.99, do not pool. First result column is D, that works. Okay. I'm going to overwrite some of those one variable statistics I did, but that was really just to check conditions and I'm done with it, so it's okay. All right. So I have an interval given here. The things I need to include are, again, I already said 2 sampled t interval, but that is what I'm doing, so I'm just going to write it again. You don't have to. Oop, I wrote t sample. 2 sample t interval. Okay, so from the calculator, I'm just going to get my lower bound and upper bound. We'll go 814 to 2.814. Okay. Again, we could have done all of this using the formula we wrote down during class up here, but it's just so much easier and faster to do it in the calculator, and these problems take so long anyways, it's probably a better idea to do it this way. I'm also going to get the degrees of freedom that the calculator gave me. Okay. So then my conclusion will be we are 99% confident that the interval, and then I'm just going to rewrite the interval. Captures the true mean difference in the number of chocolate chips in our Chips Ahoy and Great Value. Sorry, I started abbreviating because I was running out of space, but you get the idea, right? Okay. So does this interval provide convincing evidence that there's a difference in the true mean number of, oh, I added a word, in the mean number of chocolate chips? Basically what we want to look about here is this interval, since it starts out negative and goes positive, that means that 0 is in that interval. If 0 is in that interval, then we don't really have enough evidence to say that they're different, okay? So that's what we're gonna say here. Basically the type of conclusion that we would get if we were gonna fail to reject in a test of significance. So remember your interval there, that's an interval of plausible values for the true mean difference. So we don't know, it could be anything from way over here that would say that Great Value actually had more to way over here that says that Chips Ahoy has more. So since 0's in there in the interval of plausible values, we don't have convincing evidence that there's a difference. And then I'm going to go ahead and add another little bit there that says at an alpha of what? Well, how do we decide the alpha that goes with a confidence interval or a confidence level? I realize none of you can answer me right now, but if you subtract 100% minus 99%, that would tell us that our alpha would be 1%, so 0.01. At an alpha equal to 0.01. Okay? So that's about it for that example there. I believe we can probably have some time in class to go through the rest of this. If not, then I will probably just make you another video. I really want you to have time tomorrow in class to do your second checkpoint. And so I'd like you to try to watch this video and fill in the notes that we've done so far. Okay, thank you.